And we will start. So today we will discuss the last note for the model building unit, okay. And this one is regarding Boston housing. And for Boston housing dataset, you can also directly load it from sklearn, okay, and load Boston, okay, and then you will get the data set. Okay, so, and you can also get some idea about the data set with the data description, okay, and here it give you some idea about of the data set, total number of instant and attributes, okay, and detailed information about the attribute. The attribute also features called, and you can see we later on mostly will use this media price, okay, house price, media value of the price. And we will also use the number of rooms per house, okay, using those as our either for studies model, we're going to use them for our independent variables, and for machine learning, it's going to be the features, okay, and the target values. And it also said this data set also has an archive on UCMI. And if you recall, in our last note, we also mentioned UCI. So UCI has quite also a number of various data set, okay, a mature data set for machine learning and the data analysis. And if you're interested, you can go to that data set to find of the information. And so as usual, generally speaking, you want to know all of the feature names. Is it? So here, if you get to the feature name, it will give you of the feature, and you can also get to the target. Is it? And we are going to get the data as the pandas data frame as usual, and you specify which feature is going to be the columns for our data frame, okay, and which column is going to be the target, okay. So that's regarding our data frame. And then after you have the data frame, and we first are going to take a look the statistics model, okay. And so you select the independent variable. So X is in statistics models independent variables. And we select the median value price as the dependent variables. Dependent variable. And over here, we use what? OLS. So who still remember what OLS in this statistics model? So what is that OSL model? What model it is? Who still remember? For the statistics models, the OLS is
ordinary least square.
Square, yeah, very good. It is used for what? For what kind of model?
Linear regression.
Yes, very good. It's linear regression, okay. Okay, not logistic regression, is it? And not polynomial regression. And so just a quick review, linear regression versus logistic regression. And who still remember for logistic regression, normally the dependent variable value should be what? Who still remember? Normally we use it for what? Well, the binary, okay? So just logistic regression, mostly it's used for binary, etc. So the y value normally it's 0, 1, etc. And the linear regression, the purpose is to what? To find the correlation, etc, between x and y. As x can also be more than 1, etc. So multiple independent variables try to find the correlation. So which one has more role, etc., contribute to the y. Okay, so we over here, OLS, basically it's linear regression, etc. So we try to do the linear regression, and then you call the fit, okay, to fit the model. And then here, the idea for fit is what? Linear regression, basically all of the data, so like the dots, if we draw the scattered data, if you scatter plotting, that if you do the plotting on observation data, this observation data is over here, X and Y, etc. And we also call them samples. This is samples, okay. So in statistics model, etc. And in sklearn, in machine learning, we also have training data, testing data. And basically, we also have another one called validation. But so far, we saw the examples with training data and testing data, etc. But for study, it doesn't have those kind of splitting, okay? So it's all go to the observation data. And then with that, you come up with some linear equation, etc. The linear equation, so alpha and beta, you try to find the coefficient. This coefficient, how do we use to find? We use that OLS, is it ordinary least square, is it? You try, and we can, because you try to find a line, and that line will minimize the error. So we can call this is error. So this is the real one, and this is your predicted one. The difference is it. So this is y hat, and this is some yi, is it? And you try to find the square, is it? And you sum all of those points, is it? And you try to minimize this, is it? And with the minimization, is it, we can use calculus, is it, to find the derivation, is it? Then you can find the alpha and the beta expression, is it, with this expression regarding y value and x value, is it? So that's regarding the linear regression, okay? So we try to minimize, because if you use a different line, like this line, then for each point, you also have the error, etc. Okay, so anyway, so that's from statistics point of view, okay? So in machine learning, it's going to do some other way, okay? So not like the math, you derive something, okay? And if you're going to take machine learning class, then we will say its approach is a solution in another approach, okay? And after you fit the model, that we find that line, then you can use it to predict. And when you do prediction, this is the value from the samples. And it's not just use sample, you can also make a prediction with new observation data. Is that new observations? Okay. And with statistics model, the nice thing is you can get a statistics summary report. Okay, summary report. And within the summary report, what we will have is you will have detailed information, that, and you also have the R square, adjusted R square, that. And previous we also discussed R square. So if your model is good, it should be close to 1. Then it's a good model. And then over here, it will also give you the coefficient. The coefficient. This over here, it's regarding the rooms because we only have one variable, that one independent variable. And we also have the p-value. And the p-value, it's the smaller, the better. So the smaller, the better. Okay, so generally, if it is less than, if it is less than 0.005, okay, we can consider the model is good. So it looks like the model is good in this case, is it? Okay, so that's basically, it's pretty similar as what we learned from Wednesday's class. And then next is that the other example, we didn't add a constant. So it's kind of like y just equals beta x, is it? And if we also want to add the constant, so the intersection part, is it? And you can also say, okay, I want to add a constant, is it a constant? Okay, and then do the same thing. You can call linear regression and do the fit, is it? Do the fit. And you can do the prediction. You can also get a summary result. Okay, so it's similar. And then in this case, did you see we have for the summary report, you can see the R square, it's dropped a lot, is it? So it does impact, is it? And for the coefficient, then you also have the interception part, the constant, is it? And the variable, okay? And here to also give the p-value, okay? So that's regarding the statistics model. What the next part try to show is with the statistics model, okay, you can also do some plotting, okay. So here it says some regression plots, okay. And we will see with that statistics regression model, we will have 4 kinds of graph. So what are each one of it? So the first graph, it shows the dependent variable and the independent variables relationship. Okay, so it's a dependent variable against the predicted value. And also it will give you the confidence interval. Okay, so this is quite useful, is it, for visualization. So over here it shows. So this is that, so this graph is that dependent versus the independent, is it? So the predicted, so the y value against the predicted value, is it? And here, so this middle red line shows the fitted. So after you call the fit method, is it, the function, then you will get that equation, okay? So this red line shows the equation. And all of these dots, is it, the dots is the samples, okay? And over here, so this two line, the black part, is it shows the confidence interval. Confidence interval. So in statistics, it's useful, is it? And you have the X value and the Y value here, okay? So that's the first plotting, okay? First figure it will give you. And what is the second figure will show is that it's residuals versus the independent variable, okay? So what that means to show models error versus the predictor variable, okay? And here, the dot, it's still the sample value, okay? And what is the line represents the mean of the observed value. Then we can kind of see the residuals, is it the errors versus the predicted value. So here, let's see. So here, this is the graph, is it? So this is the mean value, is it? And the residual, okay, so this is regarding the residual, okay, the error residual. So of course, the mean is zero. Is it here? Then it shows all of the observed values. Then you can find the arrows. Is it the arrows? Okay, so that's the residual regarding against the predicted values. And what the third graph also shows, it's between the relationship, so it's called partial regression plot, okay? So this partial regression plot in this case, because we just have this single independent variable, okay? So it will show the relationship between these two, but it will consider also the impact of adding other independent variable, okay? So if you have a model that's not just a single single independent variable, is that you can also consider the impact of adding other, is that to this existing models coefficient. So let's see. So here it shows, is it? So here it shows a partial regression plot. So basically, this is that the equation, okay? And the next one, what it gives is called CCPR, so component plus residual plot. It says it's an extension of the partial regression plot, okay? So our trend line, so that's the equation, is it with the line. And also consider the impact of adding other independent variable, okay? So that you will get, so not just that the specific specify, so it also include the other independent variables impact, okay? So then you will have this kind of plot. So if you like more interested in statistical result, then all of this will help a lot for the interpretation, okay? And to get all the 4 plots, because with Python's matplot libraries pyplot, we just have that figure. That's the figure we define. And then we use what? We use the statistics models graph, the plot method, this specific plot regression exoc, using this specific function and plug in with the regression model, okay? And then you also specify the independent variable, okay? And this part is from the pyplot, is it? And the other part is from the statistics model, okay? So we kind of, you see, combine them together, okay? And what the next part to try to show is we can also plot the trend line, the observation and the confidence interval, okay, specifically. And if that's the case, then we need to import some other package, okay. It's a studies model sandbox regression prediction standard deviation as a WLS prediction standard deviation, okay. So you need to import this specific package. And then over here, you also specify the independent and dependent variable x, y, okay. And then you call this function, okay, WS prediction standard, and you plug in with our linear regression model, okay. And then what you can get from this method, what it returns is, it can return the confidence interval values, okay. And if you recall previously from Python, if you have this underscore, it's a dummy variable, okay, because we are not going to use it. If you want to use it, then you need to give it a name for the variable, okay. Otherwise, if this is case, it's just a dummy variable. And then you can get the confidence, lower confidence and higher upper confidence, okay, both the confidence intervals range kind of. After you have those values, and then we can also do pie plot, etc. And we can do the plotting this time. And this time, what we plot on the pie plot, okay. This time we didn't use the statistics models itself as plotting. This time, this plotting is within the pie plot. So you call the plot, and the first one is what? Is the sample. And you specify the shape of the sample data, is it? And its label, and it can be used for legend, is it? And the XY value, okay. And what the second one is going to be plot is what? You also specify plotting color, is it? And the label. And what over here, you're going to get the value from models fitted values. Okay, so you can retrieve that model, the value and the X. So the X part, and this is the Y part for our plotting, okay. And then the last one is draw the confidence upper and lower bound. Okay, so confidence upper and lower bound we retrieve from this function, etc. So the X value and the Y value, etc. And the specified color and the type, okay. And then we can take a look. So with that specification of the drawing, is it? So we can kind of get the model, is it? So this is a model. So this is a model. Basically, it's the equation, is it? And here are the samples. Sample, and this is for what? For confidence interval. Because sometimes when you do the reporting, etc., and if there is a need for statistics plotting, then you can use this kind of idea, okay, to do the visualization. Okay, so this is regarding statistics model do the linear regression. And if you recall in machine learning, so sklearn is machine learning's package, okay. We can also do linear regression, okay. So then in that case, you need to import the linear model, okay. And then over here, we get our data set and have the data frame, so nothing new, is it? And you get the target value, is it? You can also specify the X value and the Y value, is it? Looks like the X value in this case, it uses all features, is it? It didn't just use that number of room features, so it consider all of the features. And the Y value is a median price. Okay, then you are going to do what? So this case, you create a linear model, linear regression model. Okay, you first need to create, and then you train the data. So you fit the data. Okay, so then you plug in the X and Y. So plug in features and targets. Is it target value, feature value, and target value? Okay, so after you do that, your model is trained. Okay, after you train, then you can use it to predict. Is it? And generally speaking, in machine learning, we can split the data into training part and testing part. And then you can, when you do predict, you can use testing data to do prediction. Is it? Because with testing data, you also have the target value. Then you can measure the accuracy of your model, okay? And after this, you can get to the predicted values. Here it shows the top 5 predicted values. And for machine learning, then you cannot get the detailed report. That we cannot. But you can get each individual one through independent properties or method, etc. And for score, etc., you can get the score, so the percentage, so accuracy, basically. And you can also collect the coefficient. Is it? And here, because we use all features, that not just that number of rooms. So that's why the coefficient we have 13 coefficient, is it? And we also have interception because it's a linear regression. Okay, and basically if you write it's alpha plus beta x, and this x is a matrix, okay, a big matrix. So huge matrix, is it? And each column, so basically over here, we have 13 columns. Is it 13 columns? It's 13 features. And this is a matrix. Is it matrix? Okay. And then for each row is one observation. Is it one observation? Okay, for each row. So that's what for the linear regression in machine learning. And then the Y value is the mean price, is a median price. And this intercept is at alpha. So you can also get the value. And over here, so it's also because it's multiple columns. Is this so for each column, basically, so x0, x1, x2, 2, x12. Is it so for each one of it, it has a coefficient. Is a coefficient, and that's why so each one. So this is beta 0. This is beta 1. Okay, so you have a bunch of them. Is it? And this is just the vector formatting. Okay, or we call it a matrix in math, is it? Okay, so that's machine learning, and then you can also get intercept. Okay, so pretty straightforward, we can see, is it? Okay, so that's all regarding model building. Okay, so we complete the